Hi, my name is Mackenzie Gibbs, and I picked Chapter 7, Chapter 9, and Chapter 1. For the first question, it asked, where are hemoglobin and myoglobin located in the body? And this is from Chapter 7, the self-test number 1. So, hemoglobin is found in red blood cells. And myoglobin is found in muscles. So a similar question is to describe the structure of myoglobin and hemoglobin. And this is from week 2, topic 21. So for the similar question, myoglobin has 8 right-handed alpha helixes and a hydrophobic pocket in the center where the heme is. Hemoglobin is a quaternary structure. It has 4 polypeptide chains in a globin fold. And 2 identical subunits, which are called the alpha, and the other 2 identical subunits are beta. So it's question 2 from chapter 9, problem 8. Place slash marks at the sites where you would expect chymotrypsin to cleave the following polypeptide. So first it's important to know what you're starting out with, and to know what chymotrypsin cuts at. So these are the 4, and if you look at the peptide, it would cleave after each one. So here, and after there, and after there. So total, you're gonna have 4 different peptides. And the reason that you don't cut at tyrosine right there is because of this proline, and it's important to remember that you do not cut before proline. So a similar question is, instead of chymotrypsin, you have elastase. So you need to look at where that cuts, elastase, which is alanine and glycine. So this would cut here and here. So here you would have 3 different sections. This material is from week 4, topic 42 and 46. And the last question is, from chapter 1, it's number 17 in the textbook, and it is from week 1, topic 8. So an acid with a pKa of 8 is present in a solution with a pH of 6. What is the ratio of the protonated and deprotonated form of the acid? So to do this, we need to write the ratio, which this is protonated to deprotonated. And here's something important when always doing these problems to remember. So, to do this, you start off by just taking 8 and subtracting it by 6, which you get 2, and that's the number of zeros that you're going to have. So 10 to the 2, so that's just 100. So you have 100, and to know which form it's going to be in, so when pH is greater than pKa, it's going to have more of that, and on the other way, when pKa is greater than pH, you have more HA. So in this case, the pH is less than the pKa, so you're going to have more HA, so that's why it will be 100 to 1. And whenever you have the pH equals the pKa, there's going to be equal amounts of the protonated and deprotonated forms of the acid. So down here is the same question, but we have different numbers. So we have pKa equals 3 and a pH equals 6. So in this one, we just take 6 minus 3, which is 3, and that's going to be the number of zeros, so 1,000. And in this case, the pH is greater, which means there's going to be more of the A, so it's going to be for 1 to 1,000.